So let's start with the next topic. We will talk about the probabilities, values, or the p-values. In this chapter, you are going to learn about the p-values. We will also talk about the confidence intervals or the confidence limits, and we also will talk about the alpha values. So probability values are nothing but the p-values, right? So in this whole chapter, we are trying to amalgamate, we will try to integrate the understanding from epidemiology and very importantly, the understandings from the chapter on screening of disease, where we discussed about the advanced concepts in the screening of disease, errors in screening of disease, alpha errors, beta errors, and the null hypothesis. So if you have not watched that module, you need to probably watch and see what are the type 1 errors or type 2 errors, null hypothesis accepted and rejected, and the errors. And then you come over to understand what is the concepts in probability values. Anyways, let's get started and talk about the p-values. First thing is, what is a p-value? P-value means a probability value. If you watch the module in epidemiology and in screening of disease, again, we talked about the probabilities. Probability means the chance of an event to happen. It means the chance of an event to happen, and the chance is expressed in decimals. So that is your question number one. Probability value or the p-values, they range from how much to how much. The probability values or the p-values, they range from 0 to 1, 1 being the maximum probability and 0 being the lowest probability. If I take this probabilities values and drop it on a normal distribution curve, how would they look like? So on this curve, if I drop the p-values, mind it, there are two things I would like to tell you. Whenever we use p-values to be put on a normal distribution curve is a beautiful curve on which you can put odds ratios, you can make relative risk, you can even make the p-values. Slowly we will talk about the odds ratio and the relative risk. Right now, let us plot p-values on the normal distribution curve. Whenever we are plotting p-values, we don't call this as -1 standard deviation, -2 standard deviation, -3 SD, +1 SD, +2 SD, +3 SD. That we normally talk when we put the values, like the value of hemoglobin, and you're talking of the percentage of the population. So at that time, you use the standard deviations. When we talk of p-values, mind you, we talk in +1 standard errors, +2 standard errors, +3 standard errors, and we are always talking of the standard errors. And the difference between -1 and +1, it is not called as 95% or 68% population. It is called as 68% confidence limits. So there are two things I have changed over here. Only the names have changed, the concept remains the same. That whenever you plot the p-values, we use standard errors instead of standard deviation, and instead of the population, we use confidence limits words. So ±1 standard error ±1 standard error will correspond to how much confidence intervals? 68% confidence interval or confidence limit, that is same. ±2 standard error will correspond to same answer, 95% confidence interval, and ±3 standard errors will correspond to 95% confidence interval, 99% confidence interval. Are we okay with this? So these are called as the CIs or the confidence limits or the confidence intervals. So you have -1, +1, -2, +2 corresponding to 95% confidence limits, -3, +3 corresponding to 99% confidence limits. That is about the p-values. Now p-values, you know, that range from 0 to 1. If you understand all this, can you just tell me that, let us say I give a question paper to you all. It is a 100 marks question paper, and average marks which every student in the class was 150 students, they got was 70 marks was the average marks. I plotted a normal distribution curve, and that is what you're going to see. So mostly people will be hovering around 70 only, na? Maximum chance of the population will be around 70. One student was there who, poor fellow, got only maybe 20 marks or 10 marks. There was one super genius student in the class who got maybe 95, but he was only one. Majority of you and me, we were belonging to the average class and we were hovering around the mean. That means in probability words, if I talk, where is the maximum probabilities? Is it in the center of the NDC or outside the NDC? It is towards the center of the NDC. Are you understanding this? So that means if I plot the normal distribution curve on this if I plot the p-values on this normal distribution curve, the center would correspond to how much, 0 or 1? That is what my question to you is. The center will correspond to the lowest probability or the highest probability. Of course, based on the same understanding, the high probabilities are towards the center. Didn't we say that many of you will be having this much? Some of you, very few, will have outside. So based on the same understanding, the probability value will lie here to be 1. So make sure you know this. And once you go outside, towards the outside, on either side, right? On either the left side or the right side. If you go outside, the probability value is tending to decrease. Will you remember these things for me for now? So this says the base for probability values. It could range from 0 to 1. 1 being the center probability, and as you go outside, you tend to decrease. Point number 2. Let us say you conduct a research A and B. 2 groups are there. To group A, you give a drug A. To group B, you give a drug B. And then you're going to check A dash and then you're going to check B dash. What type of research study design is this? This is a randomized clinical trial. If we are going to randomize them. Simple answer. So you'd randomize them and it is called as a randomized clinical trial. Let us say you invented a drug A. You invented bedaquiline. Let us say you invented a new drug, maybe you wanted to test remdesivir in COVID-19 patients. So you wanted to test remdesivir in COVID-19 patients and you give them drug A and you give them drug B, and let us say you find an effect. Find an effect in the group A. If you find the effect in group A, what are you going to do to the null hypothesis? Will you accept the null hypothesis or will you reject the null hypothesis? Do you remember that's the same thing that we had done when we discussed about errors in epidemiology and in advanced concepts and screening of disease? We discussed about the errors, that if you reject a null hypothesis which was true, that is called as alpha errors. Null hypothesis, I think just a quick sensitizer for you, that null hypothesis can be true, it can be false, you can accept it, you can reject it, you can accept it, you can reject it. If you reject a true hypothesis, if a true hypothesis is rejected, that is called as alpha error, also called as type 1 error. And if you accept a false hypothesis, if by chance is accepted, that is called as beta error, or I told you it is called as type 2 error. So now, based on this understanding, if you're finding an effect, what is the null hypothesis? Null hypothesis states that there is no difference, right? So if you find an effect, what are you going to do to the null hypothesis? You're going to reject a null hypothesis because you found the difference. Now, let us say all this is theoretical stuff. Let us say practically me and you sit down and do the research, and let us say that initially the CRP levels of all the mean patients, of all the 100 patients in group A was, let us say, 50. And you give them remdesivir tablets or injections and whatever you can, and for 5-7 days, and then you see the CRP levels drop down to 42. So very good, we did it. But on the other drug, on the group B, let us say you were giving placebo, or let us say you were giving them zinc and vitamin C, something you were giving, some antioxidant you were giving. So there was, the CRP level was 50 and it drops down to 46. So now in group A, you can see more effect. In group B, you can see less effect. Can you say that group A is more effective or the drug A is more effective? Practically, it is not possible to do that. So what I'm telling you right now, so since last so many hours, I had been talking to you about epidemiology, about screening of disease. Right now, earlier we were just saying find an effect, not find an effect. Right now, we are actually practically going to do how to conduct this study. So what we do is, we take group A, we take group B, we give them the drug A, and we give them the drug B, and then we are going to check them B dash, and we are going to check them A dash, and we are nobody, we are not God, we are not going to assess what is happening. We take all this data, just for example, right now, just try to understand, we take all this data and we put into a computer, into a machine sort of thing. Something is called as machine. I don't know. Like later on we are going to discuss. I'm going to disclose everything later on. But right now, just assume that you take all the data, you put into a computer or a machine, and the machine was going to jumble up, do some data here and there, and it gives you one value. That value is wonderfully called as a p-value. Let us say that the p-value, I told you what is the p-value. We already discussed that the p-value will range from how much to how much, 0 to 1. Let us say that the p-value which comes out is 0.02. What does this p-value 0.02 mean to us? Are we okay with this? Now, we take this p-value and I put it on my hand. I take this p-value, put it on my hand, and I drop onto this normal distribution curve. You already know that at center point, the p-value will be 1. As you move away, the p-value decreases. You should also know one more thing, that at 2 standard errors, at plus 2 standard errors and minus 2 standard errors, at both points, the p-value is 0.05. You should be knowing this. You should be knowing this, that you already know that this plus minus 2 standard deviation or 2 standard error is what is the cutoff, right? That is the zone of normalcy. You already know this. So at this junction, the p-value on either side will be 0.05. So now in your study, how much is the p-value you got? That is 0.02. 0.02 is more than 0.05 or less than 0? Of course, it is less than 0.05. So where will it lie? Will it lie within the normal zone? Or will it lie outside the normal zone? Where do you want to make this p-value lie? In the pink zone or in the green zone? It is going to lie outside the normal zone. P-value is going to lie somewhere outside. So let us say it lies here, p is equal to 0.02. So what does this p-value 0.02 outside means? In very simple words, this is the climax of this whole story of concept of p-value. What does this p-value 0.02 means? Very important, listen to it very slowly and very carefully. P-value 0.02 means that whatever difference was there in these two groups, group A and group B, you had whatever difference, like you had this 50 coming to 42 and 50 coming to 46, whatever difference was there. In this p-value 0.02, whatever difference was there, this difference is in the abnormal zone. That means whatever difference was there, that is a real difference. That means that either the drug A is very effective or drug B is protective. That you see from yourself. But whatever the difference is there, that is not a normal difference which is occurring in humans. You remember I started my lecture with that variation is bound to occur. So if the p-value is 0.02, that means what? That the variation which you are observing right now is not a normal variation for us humans. This variation is either the drug is having the effect or the other drug is protecting it. But all said and done, there is a difference. You need to understand that p-value 0.02, that means the variation is there. So if it means that the variation is there, what should we say to this p-value? This p-value, we call it as a significant p-value. Why significant? Because we say that the variation is significant. Let us say on the other hand, by chance, the p-value had come out to be 0.08. That means what? That means 0.08 is more than 0.05. So that means if you're going back to the curve, you're going to put 0.08 where? Inside the normal zone or outside the normal zone? You're going to put somewhere here. 0.08 should be somewhere towards the center side. So that is what is the inside the normal zone. So 0.08 is going to lie inside the normal zone. That means what? That means whatever variation you are observing, that is a normal variation for us all. Therefore, we call this variation as a non-significant variation. That means that p-values can be of two types. That brings to this point that p-values can be of two types. We can have a significant p-value or we can have a non-significant p-value. What do you mean by a significant p-value? Significant p-value means that the p-value is less than 0.05. Non-significant means the p-value is more than 0.05. Point 1. What else does it mean? If the p-value is less than 0.05, that means it lies outside the normal zone. outside the normal zone, and if it is lies outside the normal zone, that means the effect is observed or not observed. It means the effect is observed or the effect is found. If the effect is found, that means what? The null hypothesis should be accepted or rejected. The null hypothesis is rejected. The null hypothesis is rejected. On the other hand, if the p-value is non-significant, that means it lies inside the normal zone. That means it is inside the normal zone. That means the p-value is more than 0.05. That is the reason it is lying inside. That means, will you observe the effect? Yes or no? No effect is observed. No effect is observed. And if no effect is observed, what do you do to the null hypothesis? Null hypothesis will be, null hypothesis is accepted. This is the high yield, most high yield chart for you. This is what you get in the exam. So please remember, when will you say a null hypothesis is accepted or rejected? It is based on the p-values, and that's the reason we say p-value significant or p-value non-significant. It means what? Probability value. Probability of what? Probability of accepting or probability of rejecting a null hypothesis. That is what means is the p-value. Next level. Let us go ahead and learn something more about the p-values. If you talk about the p-values, you already learned that p-values. You remember what was my second assumption? The second assumption was that the p-value is like the normal zone is 95% confidence, and the p-value I am saying significant, non-significant based on what? Based on the normal zone. That means this whole thing is based on an assumption. So that is the concept you need to take home. Let us move to another concept, number 2. Let us now play with the p-values. If you want to play with the p-values, let us say that this is the normal distribution curve. This whole normal distribution curve, I told you what is significant, non-significant. Significant is more than significant is less than 0.05. Non-significant is more than 0.05. It all depends on what? It all depends on the 95% confidence limit. You remember what was the second assumption? Second assumption was 95% will be taken as the normal zone. That means this whole significant, non-significant is based on a second assumption. That means that, let us say a researcher changes this assumption. A researcher says that I wish to take, research is research. Researcher says that I wish to take 68 instead of 95 as the normal zone. What will be happening to the p-values? The previously significant will remain significant, significant will become non-significant, non-significant will become significant, or non-significant will be non-significant. What do you want to say? So try understanding that previously you understood that 95 is the normal zone. Now this naughty researcher, they say that I want 68 as my normal zone. So now this becomes the normal zone. So the p-values which was lying here previously this was a non-significant p-value. Why? Because it was within the normal zone. So now because you decrease these confidence intervals, what is happening to this p-value? This will become significant. So the previously non-significant will now become significant. The previously non-significant will now become significant. Are we okay with this? So now if you understand this, that if a researcher moves from 95 to 68%, that means they are moving from 95 to 68% confidence limits. Then what is happening to 68? Then what is happening? The previously non-significant p-values will now become more significant. Are we okay with this? If the significant p-values increase, the chance of finding the effect will increase or decrease. The chance of finding the effect will increase. If you keep on finding the effect in all your researches, the chance of accepting or rejecting a null hypothesis will increase. What do you want to fill over here? Accept a null hypothesis or reject? If you find the effect every time, you are going to reject all the hypotheses. And if you keep on rejecting the null hypothesis, which error will increase? You are rejecting. The rejection hypothesis could be true, it could be false. If it is false and rejected, pretty cool. But if it is true and rejected, what error are you increasing? You are increasing an alpha error. For more details on this concept, you need to watch the modules on advanced concepts of screening of disease and this advanced concepts in epidemiology, where we discussed about the errors in epidemiology, null hypothesis true or null hypothesis false, and accepted or rejected. So please remember that this is what is going to happen if the confidence interval is decreased from 95 to 68. So nutshell, I want to say that if you decrease from 95 to 68, what is going to happen? The alpha errors will increase. Coming to the other side, let us say a naughty researcher says that I want to take 99 instead of 95. So this is again a big headache. So the researcher says that instead of 95, which was my normal zone, I wish to take 99 as my normal zone. So now previously the significance, the p-values which were lying here, previously they were significant or non-significant? Previously they will be significant. So now because you are taking this green color zone, that is the bigger zone, what will happen to this significant? The significant will now become non-significant. So that means, what is your answer? The previously significant will now become non-significant. That means what? That means if a researcher moves from 95 to 99%, that means you increase the confidence limit, the previously significant p-values will become non-significant. Are we good? Non-significant will increase. That means chance of finding an effect in the studies will increase or decrease. Chances of finding the effect will decrease. You will less find the effect. If the chance of finding the effect decreases, the chances of dash null hypothesis will increase. So if you don't find the effect, the null hypothesis, more will be accepted or rejected, more will be accepted. So chances of accepting a null hypothesis will increase. If you accept every hypothesis, if it is true and accepted, pretty cool. But if it is false and accepted, what error are you increasing? It is the beta error. Or in talking in terms of alpha errors. You remember which error is more superior, more important? It is the alpha error always we talked of. So chances of which error, beta will increase, but what happens to the alpha? The alpha will decrease. So in very nutshell, if this is your normal distribution curve, this is known as the normal zone. If you make this as the normal zone, what is going to happen to your alpha errors? You remember, if you make this as the normal zone, what is going to happen to the alpha errors? The alpha errors are going to increase. So that means the alpha errors are going to increase. And in case you make this as your normal zone, what is going to happen to your alpha errors? The alpha errors will decrease, but on the other hand, the beta errors will increase. Are we getting it? And that is the reason this is taken as a trade-off. I hope you accept my second assumption now. You are in position to understand that why did I take the second assumption? We take the second assumption that plus minus 2 will be taken as the zone or normalcy, because if you decrease inside the alpha increase, you go outside the beta increase. So that's a kind of a trade-off phenomena. So with that, you finish this topic on understanding the concepts of p-values in relation to the confidence interval as well. Next, let us talk about the alpha errors. Another point that you need to do along with the concepts of p-value is understanding what is this alpha error. Alpha error, I don't want to show you this definition, but I have to, because that is what is the definition. You must be laughing at this definition, smiling at this definition. It is the probability of finding an effect just by chance. It is the probability of finding an effect just by chance, which in reality does not exist. So the probability of finding an effect just by chance, that is what is alpha error. Alpha errors, technically it is also called as the alpha level, and they are also called as the alpha value also, right? So if you recall our lectures, we already talked in screening of disease that alpha errors correspond to the false positive errors. They also correspond to the type 1 errors. You remember this? Alpha errors or the false positive errors or the type 1 errors, they all mean the same. They all conceptually mean the same. Okay. Anyways, what is an alpha error? Alpha error corresponds to the confidence interval or the confidence limit. It corresponds to the confidence interval or the confidence limit or the p-value. See, what happens is, let us say your study, in the previous case I think we had taken, let us say that the study gives us a p-value of 0.02. What does this mean? Let us say you want to do a research that you want to find out what is this I am holding. Is this a pen? Is this a remote because it has some buttons? Is it a pointer? Is it a slide changer? Is it a stylus? Is it a eraser? What is it? Is it a pencil or it's nothing? So you want to find out what is this. You do a research to find out that is this a pen? That is your alternate hypothesis. So what is your null hypothesis? Null hypothesis, this is not a pen, right? Null hypothesis, this is not a pen. So let's do research. On research, you find out that the p-value is 0.02 with 95% confidence limits. You say that this is my confidence limits. But mind you that p-value, let us say 0.02, it also corresponds to an alpha value of, let us say 2%. So what does this alpha error or alpha level 2% means? It means that, listen carefully now. It means that I did a research to find out whether this is a pen. So my null hypothesis was this is not a pen. I did my research. I found out that the alpha level is 2% and the p-value is 0.02. It means that this is a pen, right? Because p-value is 0.02, it is significant. So I reject my null hypothesis. I accept my alternate hypothesis, right? But the alpha level is 2%. It also means that there is a 2% chance that this is not a pen and it is something else, because I'm not God. Any research that I do, there is a chance of error. That chance of error of finding an effect which in reality does not exist is called as an alpha error. That means this is a pen. My study says 0.02 significance. That means this is a pen. But there is a 2% chance that this could not be a pen. Are we getting it? So if you put it on a normal distribution curve, if it is 0.02, that means it is lying here, right? P-value is 0.05 at two standard errors. So this P-value is lying here, 0.02, right? So this is, let us say it corresponds to alpha level of 2%. That means there is 2% chance that this is not a pen or something else. Or in other words, listen carefully, I am 98% confident that this is a pen. That means this tells you the level of confidence at that particular point. So in other words, 2% alpha means 98% confidence. So 68% confidence will mean how much? At this junction, 68% confidence will be how much alpha level? Won't it be 32% alpha? So 95% will be corresponding to how much alpha? 5% alpha. 99 will correspond to how much alpha? 1% alpha. 97 will correspond to 3% alpha. That means the more you go inside, mark my words, the more you go inside the normal distribution curves, the alpha level increases. The alpha level will increase, and if you go outside, the alpha level will decrease. So don't you think you had done the same thing just a while ago? Just a while ago, you had done the same thing. So don't get scared. I am just showing you the same phenomena with different camera viewpoints. First, I showed you about the normal distribution. Then I showed you about the alpha values in terms of confidence limits. And now I am showing you the alpha levels in terms of alpha values in terms of the confidence intervals and the p-values. You also had learned what is a false positive error rate. False positive error rate is chance of finding a disease in a healthy patient. You also know what is a type 1 error. Type 1 error is chance of rejecting a hypothesis, rejecting a true null hypothesis. You also know what is alpha error. Alpha error is chance of finding an effect which in reality is not there. It is not there. So don't you think all three things mean the same? Chance of finding a disease in a person who's healthy is chance of finding an effect which in reality did not exist, is chance of finding an effect and rejecting a null hypothesis which in reality was true. It means the same thing here. Are you understanding? False positive, type 1 errors, alpha errors, they all mean the same thing. They all mean the chance of finding an effect just by chance, which in reality does not exist. That's the essence of understanding the p-values. Anyways, take-home message is just one, that p-value less than 0.05 means a significant p-value. p-value more than 0.05 means a non-significant p-value. Whenever you come inside the normal distribution curve, the alphas will increase. You go outside, the alphas will decrease, but the betas will increase. So you need to hang around in between. That is what is the trade-off phenomena. So with that, if you have understood many things over here, of course, if you have understood 100%, then you are the best. But if you have understood majority of the things, you're still way more, and I would like to congratulate you for finishing this topic. Thank you so much for watching me.